Hi everyone, this is Stephen Baez. I'm here to demo a few additional examples on the General Manager Dashboard. If you haven't watched the lengthier video, I'll put the link in the description that goes over how these models were developed, touching on the optimization model, the predictive model, and then the player cluster analysis model. Feel free to pause this video and watch that one first. It'll help make a lot more sense of this dashboard as we go through a number of different examples. The intent of this video is really just to go through other scenarios and use cases that this dashboard can also serve going forward for GMs as they begin to make roster changes looking into the 2022 season. So we'll take a look at a few different examples. To do so, we'll navigate first to the Constraints tab, and we'll look at a few different scenarios that a GM may find themselves in throughout the course of a season. So right now, if you watched the previous video, we were looking to return back an entire 26-man roster, including 9 bullpen pitchers. For this example, we're actually going to look to return back just 3 players. So first, I'll go ahead and zero out all the constraints. Okay, with all the constraints set to 0, we can then walk through a number of different scenarios that the general manager may find themselves in throughout the course of a season. Um, Scenario one is they are looking to increase their team's on base percentage. So one of the driving factors in predicting wins is on base percentage. And if you watch our previous video, we go into great length describing our prediction model and how that's one of the variables that gets heavily weighted. So a GM comes into this dashboard and they're looking to potentially return back 3 players. They have a need for any of these players to play in the outfield. So we'll go to the left field constraint and we'll say greater than or equal to 0. We'll also do the same for center field and the same for right field as well. So essentially, we're going to be picking players that meet our constraints over on the left-hand side. And we're looking to spend no more than $13 million on these 3 players. So for max annual salary, we'll enter $13 million. From our objective function, we will set this equals to on base percentage. We're not interested so much in minimum at bats in this particular scenario. So we're okay with introducing outliers or less experienced players. Again, because we're reducing our annual salary that we're looking to spend on players, we're okay if we have to spend less on players. So technically, we have to look at players with less experience. More experienced players that would increase our on base percentage would cost more. So we'll set this equals to 30. So essentially, we're introducing some outliers and some less experienced players. And then again, one of the other constraints is that we're looking to return back no more than 3 players. Now, as we look at the bullpen, we'll just add 1 pitcher in here as well that we're looking to spend no more than $3 million on that particular pitcher. And we'll set this equals to 1. And for the pitcher, we're just looking to increase wins overall. All right, so looking here, what we can also do is change our max player salary on the right-hand side under mission control. So we're not looking to spend any more than roughly $5 million on any one player. So this is a player level filter. And the starters aren't exactly 100% relevant here, but we'll set this equals to on base percentage. Again, we're only looking to return back 3 field players, 1 pitcher. So when I click back, the model is essentially going to return back 3 outfielders. It will determine how many left fielders and center fielders and right fielders it selects by maximizing our on base percentage statement. It's going to spend no more than $13 million in doing so. It can theoretically return back all left fielders. It can return back all center fielders. We're hoping that it finds a balance across left field or outfield positions. So I'll click back and we'll look to see who the model returns. And it takes roughly a minute and 30 seconds for it to run. During this time, it's going to run the optimization model. So send this information to the R server, send that information back. It will also determine who the starters are, update the player statistics on the bottom of the baseball diamond, update team standings, and then determine if there are other players that are similar through cluster analysis to those that return back. So I'll pause the video. I'll come back once the optimization model runs and we'll look at the output. Finish running. As we can see, it placed our starters on the baseball diamond. It also updated the statistics beneath as well. So you can see here the model returned back 4 players, 3 of whom are field players and batters, 1 who's a pitcher, and it shows their aggregate statistics. And again, here's our on-base percentage. So this is the value that we were looking to maximize. So when looking at the 3 players that were returned back for the outfield, we can see that they have an on-base percentage of roughly 430, so very high relative to other teams and other players. These 3 players would maximize, based on our constraint, our salary constraint, our overall on-base percentage. What we can also explore in the dashboard is our full roster. So we can see here only 2 outfielders are actually being shown, which means the model selected a 3rd outfielder, but essentially didn't deem that person a starter. So we can see here we have 2 right fielders, and in this case, it selected Brandon Nimmo to be the right fielder and Greg Allen to essentially be our bench player based on our mission control statement for starters. As we look around the dashboard, we can look at our wins. Our wins, in this case, because we're not returning back a full 26-man roster, wins don't really have a heavy weight associated with them. It's just a good indicator of how well these players would perform. We can look at our payroll, which is relevant here. So we're spending $2.3 million for all 4 players. When looking just at our field players, we're at $1.7 million. So what's interesting here is that when we look back at our constraint, we can see that we entered a max salary of $13 million, for which we're actually only spending on our outfielders $1.7 million. So what this tells us is that our objective statement was able to maximize our objective statement was maximized at roughly $1.7 million across those 3 players. So a significant savings while returning back the most optimal players to increase or maximize our on-base percentage. And that's really the intent of this model. It's really to put in a number of constraints, a number of position constraints, salary constraints, and try to return back players that are at a big cost reduction. So trying to maximize a certain function while staying beneath an annual salary and trying to find players that help you to stay well beneath that. And that's exactly what the scenario shows, is that we were able to return back 3 outfielders, 1 pitcher, combined for $2.3 million. Outfielders just $1.7 million. So another good example of how this dashboard could be used. And then through player cluster analysis, if we were interested in possibly exploring other players, we'll click on Juan Soto, for example, and this will filter the scatter plot located on the bottom right. And we can see Juan Soto on the top right, clustered in blue. But these are other outfielders, and as I hover over, these are other center fielders who are interchangeable. So they're not returned by the optimization model because they're not the most ideal player that maximizes our on-base percentage. Juan Soto is. But these are other players that are a close second that, as a general manager, you may want to take into account. So again, Juan Soto is the best player, and that's why he was returned by the optimization model for increasing our on-base percentage. But these are other players that would be a quick second, that maybe there's some underlying factor that our modeling didn't take into account, that a general manager would be more inclined to heavily weight these players. And so that's what the cluster analysis will show. And you can actually toggle the Y and X axes accordingly. So we'll actually take a look at relevant statistics. And some of the statistics that we can add into here as well is on base percentage. So again, just a really helpful way of looking at other players such as Juan Soto that are similar. And here we have, from a hitting perspective, Juan Soto is very similar to Byron Buxton. He's also very similar to Cedric Mullins as well, and that's really the intent of the player cluster analysis, to identify other players who are very similar to the player that you've selected. So just another example, we'll take a look at one last example by going over to the constraints tab again. There are a number of different use cases that this dashboard has been designed to support. This is just one. If you watch the original video, we went through a process of selecting a 26-man roster, but we'll go through one more scenario, and then we'll kind of discuss other use cases that this dashboard can serve without actually going through the process of updating the constraints to show it. Okay, so as a general manager, you're told midway through the season that based on how the team's performing, there has to be salary cuts and player cuts, and you're unsure of who to keep and who to get rid of on your team. There are a number of players that are very similar, that overlap in similar positions, have similar statistics, and you need to determine who you want to retain and who you essentially want to trade or potentially just release from the ball club. So by navigating over to the constraints tab, what we can do in this case is we can say that we're looking for exactly one player in every single position. So I'm just going to go ahead and quickly update all of our constraints to equals 2 and 1. And we're going to leave our bullpen equals to, in this case, we'll just set our bullpen at the end of this equals to we'll set it equals to 5, and this is the number that we'll actually end up playing around a little bit with. And for this example, we're not going to return back designated hitters or designated pitchers. That's irrelevant for us. And we know that for field players, previously we were paying $98 million, and because of price cuts and salary cuts, we now only have roughly $50 million to spend or to retain. And we want to try to maximize wins this year by retaining players. So we're going to set our objective statement to team 62 wins. Again, if you refer back to the other video that went into great detail in terms of how Team 62 Wins was designed, this is our proprietary logic that essentially passes through a multivariable linear regression model into our objective function. So we're going to select Team 62 Wins. We will move our up bats to 80. Again, we want to retain back more experienced players if possible. So looking at our field positions, we have exactly 3 outfielders, 4. So this will be equals to 9. And then lastly, we'll actually set this equals to 8, and then we'll set our bullpen equals to 5. And for bullpen players, we're looking to spend no more than, in this case, let's say it was $10 million for 5 bullpen players. Actually, just for the purposes of running this, I'll set it equals to $15 million just to see if we get a really good example of this. All right, so I'm going to click back. Essentially, this is just going to return back starters. And we want our starters to essentially be Team 62 Wins. Again, starters don't really matter because we're only returning back one player for every position. So with that said, I'll click back and we'll look to see who this model returns. And one additional filter that we're going to apply afterwards. And so right now it's going to go through every single player within Major League Baseball, and it's going to look to see who maximizes our objective function within the salary constraints. But one additional step we're going to take is actually apply a team filter. So we're going to look at just specifically one team, and we'll have the model rerun. So right now it's just going to run for all of Major League Baseball. I will click pause on the video just so that it's faster on your end. I'll move this out of the way, and you can see here that the model is clearly running in the back. Once we have a full team selected, I'll resume the video, and then we'll take the next step on filtering on one team. So the optimization model just ran. We can see the players that it had returned back. So again, if we look at the bottom statistics, it returned back 13 players, 8 of whom are batters and field players. So those are the players that you see on the field, and 5 are pitchers. Again, if we look at the full roster, we can see the breakout of who those pitchers are. So again, we have 5 pitchers, which is pretty common within Major League Baseball just for the starting rotation. And then we just have our starters as well. So what I'll do is I'll just apply a filter to return back one individual team. And this is how this dashboard can be more generalized. So we'll take a look at the Boston Red Sox, and we'll look to see who, based on those constraints that we had entered, should be retained from the Boston Red Sox starting lineup. So it's going to look through every single player that's currently on the Boston Red Sox, for which there could be a 42-man roster. And it's going to look to retain back only those starters, and it's going to try to optimize our objective statement while remaining underneath our annual player salary for an entire team. So we can look to see as this runs, I'll just move this up out of the way and we can look to see which players it's retaining. And each of these images should actually begin to change to Boston Red Sox players. And you could run this for any team as well. So again, we're just repurposing this dashboard now to answer a different question. And it's basically just running through the Boston Red Sox players and it's identifying which ones we should retain based on the salary cut, based on our objective of trying to win games. So yeah, just another use case. You could apply this to any team as well. So we'll just give this a few more seconds. All right, so the model just finished running, and if we click on full roster, we can look to see who was returned back. And again, hovering over will give you the player card. And so these are all the starters that we should return back if we were the Boston Red Sox, and if we were looking to maximize our chance of winning games, and if we were faced by a big salary cut midway through the season, and we were just looking to retain starters with somewhat of experience based on the minimum at bats constraint and minimums pitching innings pitched constraint that we had also entered. So this is just another use case for this dashboard. You could apply this to any team as well. So again, we could come in here, deselect the Boston Red Sox, select another team, and determine who the starters would be based on that salary constraint. You could do this for an individual position as well. So if there was a big cut in a particular position and now you had to fill a first baseman, you could essentially zero out all your constraints with the exception of first base and to the salary that you're looking to backfill that position at. And look to see who gets returned, whether you're looking to trade with a specific ball club. So another scenario could also be that you're the Boston Red Sox and you have a trade opportunity with, let's say, Baltimore. So what I can do is actually rerun the model and I can look to see between Baltimore and the Boston Red Sox, who are those players that we would want to keep if we had the opportunity to try to maximize our objective function of winning games. And so now the model is going to go through the process of determining between the Boston Red Sox and Baltimore, which players should we try to either trade for or retain if our goal is to try to maximize our chance of winning games while staying underneath our salary constraint that we have for the upcoming season. So we can see here it's selected first baseman from Baltimore. It also selected the center fielder from Baltimore. That would be a better selection than who the Red Sox currently have. And it will go through each position and it'll essentially identify if by trying to maximize the team's overall chance of the winning, if that requires trading for a player who's on Baltimore. So again, we're just repurposing the dashboard, looking at different use cases that these models are designed to support. Um, so once it's finished running, we'll look at the aggregate statistics beneath. It should just take another second. It's probably selecting a number of pitchers on the back end, so we'll take a look at the full roster. So we've identified our best pitcher, but I'm sure if we look at the full roster, actually it looks like all the pitchers on the Red Sox, if we're looking to maximize wins, are the best pitchers to retain and not necessarily the trade for anyone on Baltimore. But we can see here it did select two Baltimore players. It selected a first baseman as well as a center fielder. So those are players that we would possibly want to introduce into our starting rotation if we had the opportunity to trade for them. So we would essentially trade our first baseman for this first baseman if that was an option, as well as center fielder from the Red Sox. So again, different use cases. You can think of a number of different problems that this dashboard could answer. We just took a look at two. If you were looking to update a full 26-man roster, I highly recommend that you take a look at our more in-depth detail video, which goes through the process of answering a very specific question that was presented to us by our general manager. There's a link in the description to that video. If you have any questions, certainly recommend reaching out. Again, Stephen Baez, and happy to demo the general manager dashboard with you.